Okay, good morning, everyone. Maybe we can slowly start. Well, I know that there are more students registered, so some might still join us. So let's start slowly. Welcome to the course Cartographic Visualization in GIS. My name is Kamyar, and I will be the main lecturer for this course this spring. So it's going to be an intensive period of making maps, and hopefully it will be fun, and we will learn. We will practice making beautiful maps, effective maps, but also we will have fun while doing so. Yeah, so a bit about me. I believe some of you have already seen me in other courses or here and there. So I'm a lecturer in geoinformatics here at the Department of Geosciences and Geography in University of Helsinki. I have a background in geoinformatics from Aalto University. And so I was studying technical things, and along my studies, I got interested in the urban side of the urban applications of GIS and working with people. That's why I took my research during my doctoral studies toward urban studies. So my background is mostly in applications of geoinformatics or developing tools for urban research. So that's a bit about my background. Yeah, so this is the agenda for today. I already welcomed you to the course. I will welcome you a bit more, give you a bit more details about the course and what to expect this spring. And then we will get into the lecture materials for today. We will have a brief review of cartography. All of you here have either, I know that we have a lot of students from Aalto University studying geoinformatics. We have students from our department here, geography. So all of you have a lot of experience in GIS and map making. So a lot of the things that we cover at the beginning might be things that you already know. But anyway, we will have a gentle start into cartography, and then we get to the design matters. And today we will have a guest presenter, Mikko Kangasmaa. Those of you who study here might remember him. He was a student here. He graduated not long ago. So he will be talking. He took this course last year. So he will be talking about his experience in general making maps, and particularly what he did during this course last year. And so that's the agenda for today. I already introduced myself. We also have Tatu Lepämäki, who is the co-lecturer in this course. Maybe you can introduce yourself a bit.
Yeah, hi, so I'm Tatu. It's okay. Yeah, so hi everyone, I'm Tatu. So I'm a PhD researcher here at the sort of tail end of my PhD. And I need to go write it afterwards, so that's how I can join for many of these lectures. But yeah, nice to have all of you here. I've been in charge of the QGIS version. So as Kamyar will tell you, one of the nice things, or really nice things of the course is that you have the option to use whatever tools you choose. And then you have sort of these tutorials for Python and QGIS approaches. So I've been developing those QGIS versions, and if you choose to do that, so you'll find my recordings of the sort of tutorials there. Maybe a quick thing about the QGIS stuff. So I recorded them last year. Nothing has really changed about them, so I didn't update the videos. You can use whichever version of QGIS you wish, but I recommend choosing the current long-term release. So they recently updated to version 4, which these tutorials haven't been tested for. I don't think anything will broke, but you'll have a smoother time if you pick one of the versions starting with 3. So keep that in mind. I think that's about it for me. So if you have anything about the things to ask, or especially about the QGIS versions of the tutorials, so you can find me in the course's Discord channel, or I guess email, but I think the Discord will be the quickest way to reach me about the course matters. So good luck with the course.
Yeah, thanks for joining us. Yeah, okay, see you later. Okay, so Tatu will be in charge of the QGIS mostly, and then we have Ronia Siurua, who will be the course assistant. So you will see her in the help sessions, and also she will be active on Discord, giving you support if you need it. So this is the crew for this year. So a bit more about the course. Well, it's a 5-credit course. We will have lectures every Tuesday like now, so from 9:15 to 12 in the same space. The only exception, and I will still send an email to make sure everyone remembers, is that next week the lecture will be on Wednesday instead. And the reason is that some of you might have noticed that this year we are hosting the Geoinformatics Research Days at the department. So it's next Monday and Tuesday, and it's in Portania. So I will be in Portania, and some of you might have already registered, but well, the registration is closed, but if you are interested, you're welcome to join. So it's in Portania next Monday and Tuesday from early morning all the way to the evening. And I will share more information on my next slide about that. So that's why we will not have a lecture next Tuesday. Instead, we will have it on Wednesday. We have our tutorials recorded. The first year, this is the third time we are teaching this course. The first year we had in-person tutorials, and that didn't work so well because there were so many meetings per week, and the students are usually busy during May, so we decided to record it, and it worked well last year. So tutorials are recorded, and I will tell you what is the idea behind all these pieces soon, so it will make sense. And then we have the help sessions on Wednesdays, which are in the same building, in the GIS rooms. So it's in the morning and afternoon. The only exception is next Wednesday, because we have the lecture on Wednesday morning. There will be no help session. It will be only in the afternoon. And the exercise deadline. So the course, again, I will get back to the grading, but we have exercises. So every week you will have one exercise and a final portfolio or project at the end. And the deadline for the exercise is end of Thursday the following week. And the reason why it's a bit long, so the exercises are released the same day as we have the lectures, like today. The reason why the deadline is a bit long is that, well, you have the lectures on Tuesday and the health session is already tomorrow. So many of you may not have had the chance to look at the materials yet. So we put the deadline a bit later with the idea that you will have 2 help sessions in between. So if you need help, you can get help before the deadline. So this is about the Geoinformatics Research Days that I mentioned. So it's an event, annual event organized by FugiNet. Some of you might know it's this network of geoinformatics across many universities in Finland. And this year we are trying to, but it used to be a bit smaller scale event. This year we tried to make it a bit bigger. It's become a bit more international. And we have like more than 40 presentations and keynotes and parallel sessions. So it will be for sure interesting to many of you. So I encourage you to join. And it's about geoinformatics, so it covers anything from remote sensing, GIS, cartography, and applied uses of GIS as well, and remote sensing. So it's very wide. Just check out the sessions and see what is interesting to you, and you're welcome to join. So about the course environment, Tatu already mentioned that you have the option of either using Python to produce maps or QGIS, or actually anything else that you might be interested in. We will give you support. So the idea is to produce maps in this course. It's not so much about doing like sophisticated GIS analysis. It's more about the output and how you communicate your results. And as long as you do it efficiently, it doesn't matter what tool you use. So we give you support to do things using Python or QGIS, but you're free to choose anything else. Like a year ago, 2 years ago, we had this exchange of students from Germany, and they were very comfortable using R for producing maps and doing GIS. We could not help them with R, but it was fine that they used R. So if there's any other software, or we have had the students who had a background in design, and they ended up using like software such as Photoshop or like similar design software to improve visuals, and their maps looked very nice. So we couldn't help them with Photoshop, for instance, but they were welcome to use it. So you have freedom in choice of tools for producing the maps. For those of you who will end up using, and what we encourage in this course is to try them both. It's fine if you just use one of them if you're comfortable with that. But we encourage you to use Python and QGIS. So what the students usually end up doing is a combination of the two. So for the same exercise, you might do a piece of the work in Python, then take it to QGIS, or it could be that 1 week you prefer to do it in QGIS and 1 week in Python. And that's how it is usually in real life. Like many of us who do GIS for research or for our work, we are just jumping between software and programming. So that is usually the case. So I encourage you to do something similar. So for those of you who are going to use Python for the work. Of course, you can create your own local environment. Those of you who take the Python path, I imagine might have taken courses similar to GeoPython and AutoGIS, so the same logic applies here. We have a NOPE environment, which is a CSC service. So it's a ready-made environment with a lot of libraries already installed. There is information how to join on the course's website. But for those of you who will use mostly QGIS, you don't really need NOPE. You can still get the data. I guess you can also directly download it from the course's website, but also you can get it from NOPE. Yeah, so the course's website. So as I already said in my email a few days ago, everything that happens in this course is basically on the website. I forgot to mention, but I'm recording this lecture. So lectures are recorded and they're uploaded probably the same day in the afternoon, in the evening to the course's website. All the materials are shared there. We use Moodle basically for only submitting exercises and for final projects. So it's just a place for uploading things. Otherwise, we don't use Moodle so much. Then we have Discord for communication. So I've already sent you an invitation link. And yeah, so if you have any, the announcements will be made mainly there. Maybe important ones will be also sent via email. But most of the announcements will be on Discord, and we will be there most of the time. If you have questions, we are there to help you. So those are the environments we are using for the course this year. So what is the logic behind the course? We have these lectures on Tuesdays, with the exception of next week that is on Wednesday. And the idea is that during the lectures, we go through some of the theories. Today, the lecture is a bit maybe more monotonic because it's the first lecture. We will have some discussions, but there are a lot of things to cover. But the idea is that we have these interactive sessions, we have discussions, we go through mainly theories of how to make a good map. Then knowing what a good map is not enough. You should also have the skills to do those. Because you might look at the map and you love the visuals, but you don't know how to make those visuals yourself. So that's the idea behind the tutorials that we have, those recordings. So we learn some things during the class, like how to make a map look nicer. In the tutorial, we see how to do that in Python and QGIS. And so that's the idea behind tutorial. You learn how to apply the theory you have learned in practice. So the tutorial doesn't necessarily teach you how to make. It's a bit like more on the technical side, so don't take it as an example of the most beautiful map, what we make there, but as a way of creating that kind of map. So it's up to you to make the map look nicer. So it's a bit more technical, and as Tato mentioned, there will be 2 recordings every week, one for QGIS, one for Python. They are mostly similar, so the maps that we produce in QGIS and Python are kind of similar, working with same kind of data set. But they're not always identical because sometimes you can do something very easily in Python, but in QGIS it's not as easy. So it might be a bit different. That's why I encourage you to check out both, because the maps won't be identical, but quite similar. And then we have the help sessions, which are optional. And as I said, it's a place where you can show up and ask your questions. Yeah, and if at any point you have questions, just feel free to interrupt me. Yeah, so about the grading. So the grading, we have exercises every week, each of them accounting for 10% of your grade. So you will have 4 weeks, 4 exercises. In total, 40% of your grade comes from the weekly exercises. Then we have a final portfolio that we will start talking about maybe from week 2 or 3. And that will be 40% of your grade. And then there's another 20%, which is for being active, so extra merit. So we have this sophisticated formula to calculate this, but what it comes from your class activity. For example, your presence in the class, how widely you use different methods. Like if it's a bonus, it's not a requirement, but you get a bonus to your grade if you end up using different tools, if you experiment with new tools. And if your work is exceptional, because some students create very simple maps, the same thing as you have done in all your other GIS courses, and that's not the goal. The goal here is to spend a bit more time on the map. So if you make exceptional work, that will be also rewarded in your grading. So I got a lot of questions from students, most of whom are not probably here, that is it mandatory to participate in the class? And the answer is that no, it's not mandatory. We still check the presence, but you won't get a penalty. It's just that you will be rewarded if you are active here. And part of the activity comes from being in the class. And of course, generally, students who are in the class can do better in their exercises because you will also need to reflect on the exercise and what you have learned during the week. But yeah, so if you miss a class, it's okay. You don't have to write me an email or anything, but it's recommended that you join the class. Yeah, so this is one thing that I want to highlight a lot during this course, and that is that this is a great place, or we try to make it a great place for you to be creative and try new things. So it's not so much about doing very sophisticated analysis. You might do that, and it's okay, but that's not what you will be graded based on. Of course, you need to process the data to produce some map, but the goal is not to do very advanced analysis. The goal is to spend that time on making the map nice. And be creative, to be brave. So many of us have developed these habits over the years making maps. You use certain kind of colors. You don't dare to use another color. There are certain tools you use. So just here is a place where you won't be really judged. So you can be trying different tools, different colors, different things that we learned during this course. So be creative, and you will not regret it. You will become more confident cartographer by the end of this intensive course. Yeah, so let's have a quick look. Do you have any questions? If not, we can take a quick look at the course's website. OK, so this is the course's website, and I believe most of you have already visited it. So there's a lot of information about different things that I won't go through. The general information, many of which we went through already, about lectures and what happens and where. About the course environment, we already talked about that. And I have put a link here to AutoGIS course because a lot of information is the same. So if you don't remember how to use the environments, for example, Noppe and GitHub, you can check it from there. We already talked about grading, and there's some extra information here as well. About learning goals, so every week we will cover a different topic. And yeah, so we cover different topics, and you will learn to create different maps. So we start with very fundamental things today. For example, we will start with talking about projection, and we'll cover some of the basics of color, for instance. But we will revisit many of these topics again during the weeks, and we open it up. So today we talk very briefly about colors, but next week we have a lot of materials, a lot of activities on the color topic. So every week we will have different topics, and here you can check what are the learning goals for every week. Creating a Python GIS environment. So this is something I've been encouraging the students to do in my other courses as well. We have the Noppe environment, but if you want to use Python, I encourage you to create your own Python environment as a practice. But you don't need to. You can use also the Noppe, which is ready. About use of AI tools, there are some instructions here. I'm personally pro use of AI as long as it's done reasonably. But luckily, the generative models cannot produce very decent maps yet. So I'm not worried about you producing a map directly in the generative AI. But just be mindful of how you use it. Use it responsibly. It is good it's OK if you get a bit of help for your code. Many people use it. It's fine. But not for writing text or just use it reasonably. But generally, I'm fine with responsible use of AI. But there's more information here that you can check out. Resources for this course, there are some sources we have used. Well, there are some articles, there are some textbooks we are using, but you don't really need, unless you want to read more about a certain topic, you do not need them. It's enough you just follow what we publish on the course's website and the lectures and the slides. But there are some useful links here if you want to learn more about some of the topics. Yeah, and this is an open course. So I know that other people from around the world are also using the materials for their teaching, which is a nice thing. Yep, so this is the structure of so every week there will be these 2 sections published. So we have a lesson 1 this week. Then we have nothing here, but later today we will have the slides added here and the lecture recording. And then this week we have some interactive tools that you can work with. And then we have the practical part. In the practical part, we have the tutorials already uploaded. So there is a QGIS version and the Python version of the tutorial. And yeah, and everything you need for the exercise. So the exercise is already published here. So that's the overall structure of the website. Yeah, we have as you can see, we have a very diverse range of backgrounds, and it's great to have you here. And you all seem to be in the right place. We are here we all have good technical skills, or good enough technical skills to produce maps. And now we want to just think about how we can make the maps better. So you're all in the right place. So let's get started with a bit of motivation. Well, it's a famous saying, probably I've heard 1,000 times, that the picture is worth 1,000 words. Like, it has happened very often to us. You're talking about something, it's just so hard to explain it, describe it. But instead, you can just show a picture to someone, and it just speaks 1,000 words. So that's one of the main motivations behind visualizations. And visualization is not only in geography or GIS, but in general. A visual representation can reveal things that numbers do not. A classic example of this that you often see in data science courses or cartography courses is the Anscombe quartet that I will show you in the next slide. And a geography map can show you a special relation. So visualization in general is important, but particularly in geography and GIS, because in GIS and geography we are dealing with special relationships, many of which are very intuitive. So you can, if you look at a map, you can see, for example, if you have a bunch of polygons, it's easy to see what is neighbor to what. But describing everything takes more effort. So with maps, with geographic data, visualization is particularly important. As some of you mentioned, making maps is a major motivation for some of you who are getting familiar with GIS. And maps are important communication and decision support tools. And we are going to open this up soon, but let's look at the Anscombe quartet. So Anscombe was a statistician from 20th century. He passed away not very long time ago, actually. So he was a statistician who came up with these 4 data sets. Have you seen this before, this example? Yeah, so this data sets he created, we have X and Y. If you analyze them statistically, you end up with these. So they look identical. So you can see almost identical. So if you calculate the mean variance of X and Y for each of them, you end up with the very similar values. For example, the mean of the Y coordinate is 750 for both of them up to 2 decimals. So if you just purely judge this data based on analysis, you might assume that, okay, these data sets are very similar, or they're almost identical based on the basic calculations, the correlation, linear regression. Everything seems similar. But once you visualize them, they're actually very different. So this is an example showing you that visualization is important. Even if your results are very convincing, you do some statistical analysis and it really seems convincing, it is often not enough. It's a good idea to look at the visualization as well. So numbers can be deceiving. So can pictures. So it's not that the picture will tell you the whole truth, and we are going to talk about that. But usually together, they give you a good foundation for working with your data set. So what is cartography? Cartography is the art, science, and technology of making maps. There are different ways of defining cartography if you look at different books. This is kind of the definition that we want to highlight during this course. Well, there is technology involved. All of you have technical skills. You have worked with software. You know programming, many of you. So you have very solid technical skills. But what we want to promote in this course is the artistic part of it, to see cartography as also an artistic endeavor. And it doesn't require us to be artists necessarily. I'm personally not an artist. I'm not particularly good with visual things, but there are things that you can learn. So even if you are not born to be a cartographer, there are a lot of things that you can learn, and over time you will get better and better at producing maps. So it's important to also see cartography as an art, and it is also a science. Unfortunately, it's been a bit ignored. For example, I know that in Finland we have had for a long time we didn't have a course in cartography. That was actually one of the motivations behind this course. We started this course 3 years ago, and literally there was no cartography course. You learn a bit of cartography in your GIS courses, but no course dedicated to this for at least 10, 15 years. Before there used to be a cartography course in Aalto University when I was studying there. Yeah, so it's also science. There's a lot of theory behind, and we are going to go through a lot of it during these 4 weeks. So historically, maps have been used for various purposes. Maybe one of the main motivations to create maps in the first place was navigation. So our ancestors wanted to go from point A to B, either on land or if they were sailing, and they needed maps to do that. So that was one of the major motivations. Another major motivation, which has changed very drastically, like for example, navigation is still a motivation for maps now. But one thing that has totally changed is that maps used to be a way of storing data. So you had geographical data. Where do you store it? You just draw what you know. If you know where an island is or where you can find good berries, you would just draw it on the map. So it was a way of storing geospatial information, and that has changed. Now you don't produce maps to store your data. You're storing your data in some database or on your hard disk or some on the cloud, and the map is just one visualization you produce and export in Python or QGIS or any other tool you use. So that is something that has changed. Maps have been used for planning, have been used for claiming territories, and they have also been used as works of art. So a lot of early maps that have been made were made by people who were actually artists as well. So they were like painted on canvas, and they were like artistic work. Maps are very powerful in shaping perception of a space and place. At least for me, especially if I'm in a new place and I want to think, okay, how should I go from point A to point B? What I very often visualize is a map. So instead of remembering the streets, what I visualize is a map, and like the map that you often use, like if you are using Google Maps. So it shapes your perception of a space and place. It also influences the routes of exploration. So historically, simply because there was a map of a place, it has happened that more people have ended up going there, or people have ended up migrating there because they knew that place exists. It's the same nowadays. You know, I've read a lot of articles lately about how these navigators that we use in the cars or like on our mobile phones are affecting how people choose the route. So before we had this like Google Maps or other apps that people use, this navigation maps, people had different criteria for going from point A to point B. Now you just check it on Google Maps or OpenStreetMap, and you just follow, and you might end up in the streets that otherwise you would not have explored. So they're influencing the routes of exploration, and they are, of course, used a lot for asserting political control. And this is something that we are going to revisit later in a couple of weeks, but that's one of the reasons why we need to be careful with accuracy and being correct with our maps, because they can be misused. So evolution of cartography. So they were originally used for storing geospatial data, but over the time they have been more and more used for communication. So that communication can be communication, of course, with others. You have some data, you have analyzed, you want to present it to your friends, your colleagues, I don't know, to some certain audience. So that's a primary motivation nowadays. But also it's for communicating with yourself. Like, you have a data set that doesn't talk to you as such. So if you just look at a shapefile, if you just look at the coordinates, it doesn't really tell you much. So by visualizing, you're communicating with that data, and you will see what you actually have. So this is from a well-known cartography book. So it's from, originally it was from '94, and then there was a newer version of it in 2020 Ormelink book. So maps have evolved to be more than just representations. So originally, like by originally I mean like a few decades ago, when we were just starting to produce maps more easily, when we had the GIS and computers and everything, they were means of presentation. But over the time, we have learned to produce maps that allow us to do other things. So you have visual analysis. Again, you can have a whole course on visual analysis, how to use maps, not to produce maps necessarily, but how to use maps to analyze something. So they can be used for visual analysis, making interpretation from the map. They can be used for synthesis. So you have the different layers of data. You can turn them off, turn them on. They can do map overlay. So all these things can be done with map and exploration, of course. You can explore your data and the phenomenon you're studying. And I think that this is not linear. Like in the book, especially the older version, it was presented as something linear. But I see it as something interactive now, that you jump between steps. So you present something, you analyze, you go back and forth between these different steps. So how many of you have watched that video I shared the other day? Yeah, so most of you. So I will keep this brief, just to give you a historical overview very briefly. So we have and there are different versions of this depending on how you categorize it. But we have the ancestral maps, so very ancient maps, prehistoric maps that can range from cave paintings all the way to clay tablets. And they were early special representations. They were usually very local. Of course, we didn't know much about what is happening very far from our place of residence. So they were local maps just showing you what is in your surrounding. At some point, we had the birth of world maps. This is a well-known example, the Anaximander, who was a Greek philosopher. He created this world map, which was ahead of its time. It's nothing like what we know the world now, but it was quite ahead of his time, like thinking more at a larger scale like this. And he visualized, it's a tablet, this is like a recreation of it. So he thought of the world as 3 continents. So we had Asia, Europe, and then Africa. And between them, there were some sea, like Black Sea and Mediterranean Sea, and large rivers. And of course, we were surrounded by oceans. In medieval times, we had a lot of religious influence, and you can see it quite a lot in like the symbols they have used. They also had a lot of like these biases, like depending on where the map was created. So if you were in Europe and you had made a map of the world, then you were a bit biased how you visualize the Christian world compared to the rest of the world who are not Christian. So you would put like monster elements here and there because everything outside there is hell or something like that. So there are a lot of religious biases and elements appearing in this time. But at the same time, we were a bit better at making maps. So we started to have charts for navigation because we were sailing a lot back then. There was also Islamic Golden Age. A well-known world map was created by Al-Idrisi. So he had compiled 70 maps, and he had created a very accurate, actually, for its time, representation of world maps. So a lot has happened during that time. Then we have the Renaissance, and it's the age of discovery. So cartography became more important as we were exploring the world at a different scale. And we already discovered the other continent, the American continent. We had the printing press that also changed maps quite a lot. And we had some influential cartographers. For all of us who have made maps know, for example, Mercator, who was from that time, Abraham Ortelius. So these were very influential cartographers. For example, we know Mercator for his work on the projection. Then we have the Enlightenment era and cartography. So we have the rationalism appearing. So we are a bit more empirical. We have more data. We do things more accurately based on data, not just based on ideology or religious views. Surveying became more advanced. We had different tools for doing surveying, triangulation, and precise measurement of the world. So maps start to become more accurate, especially local maps. Then we have the modern cartography, which is heavily influenced by GIS. So we started to have, already a few decades ago, computers and the geographic information system software appearing. So things started to change drastically. At the same time, we also started to have the satellite imagery and GPS. So we had a lot of data to work with and new tools to create maps with. And that really changed how maps look like. And we have cartography today. A lot of the things that happened in the modern cartography are still present. We still have access to the same tool, better versions of the same tools. GIS is still around. But one thing that has drastically changed is the amount of data availability. So if you were doing GIS in 80s, 90s, you might have had some software to work with, but getting data was not as easy. So you had to have connection with government agencies to get your hands on data. Now a lot of data is open, but also we have a lot of this open crowdsourced data. You can just go from OSM and download relatively high quality data from anywhere in the world. And that's a relatively new thing, like last 2 decades or even less. We have also some challenges. Maps are still used for, so we still have maps and power issue, contemporary issues in cartography, including privacy, surveillance, geopolitical representation. We are revisiting some of this in coming weeks. And we have some future trends happening. We tried to discuss this in our last week, but things are already starting to change. We have AI, and that is going to change how cartography is. We already have new possibilities because of AI, but also there are a lot of work on how you can implement AI or generative models to produce maps. And there has been a lot of work done on that as well. And I believe it's going to change the cartographic landscape quite a lot in coming years. Yeah, so how do we make maps? Well, first things first. Working out the projection and coordinate system. So it would have been a cartographer's dream if the Earth looked really like what an expander thought of thousands of years ago, if we had a flat disk. Then you didn't have to worry about the projection. But the world is not like that, and I'm sure we all agree about that. So we have to think about projection. So the world is complex in its shape, and there are different ways of representing it. If you think about it in the most simple way, you can think of it as a sphere, but we know it's not even a sphere. It's more like ellipsoid shape, and it's complex in its shape. So we have to have a way of modeling the Earth, and then we have to have a standard for creating the coordinate system. So you have to have the system. And those of you who are more experienced with GIS, this is obvious. You have studied this a lot before. But yeah, having agreements saying that, OK, this is the coordinate system. This is how I start from 0 for the longitude, for the latitude. So these agreements are necessary. So our lives as cartographer would have been easier if the Earth was flat. It's not, so we have to think about projections. Historically, there have been a lot of attempts to create projections. So as soon as we discovered that the Earth is not actually flat, there were a lot of efforts on creating these projections because we were creating the maps on 2 dimensions, and the world is 3-dimensional. So you have to take this 3D world to a 2D surface. And that is difficult. Just you can think of it, you have a globe like these globes that you can have on your desk in your office. So if you want to flatten that, what should you do? Well, you have to break it. And you have to imagine that it's flexible. You have to create all kinds of distortions here and there to make it flat. So that's what we are dealing with. There are thousands of projections to choose from, but there are many for a number of reasons. One is that many have tried to always come up with the magic formula to have the least compromise, because when you do that projection, you're always losing something. And mathematicians and cartographers were curious. They always thought, OK, I can do this better. That's part of the reasons why we have so many. Another reason is that, of course, for different purposes, for different geographical areas, you end up using different projection systems. So there are thousands to choose from, many of which are well known. You can find it like in QGIS or Python libraries. There are also a lot of them out there that are not even listed officially. So coordinate system. So it's important to distinguish the two. So we have geographic coordinate system, and this is not projected. So you have your longitude and latitude, and you're still on the 3D world. But then you need projected coordinate system. And why do you need projected coordinate system? Well, one example is for cartography. Your maps are still 2-dimensional. Whether it's printed or on your screen, it's in 2D. So you need to convert your world from 3D to 2D. But also you need projection for your calculations. So if you want to get the distance from point to A, from point A to B, then you cannot measure the distance in degrees, so in longitude and latitude. So even if you can calculate the distance, it's not the same. For example, 1 degree on equator is not the same distance as 1 degree in Nordics. Or in North Pole, basically the distance is 0 between degrees. So if you want to do calculations, area, distance, or if you want to produce a 2-dimensional map, you need to do projection, essentially. So with projection, there is always something you lose. And I know this is something you have studied in courses, so I won't go through details. The point here is to just remind you that this is an important part of cartography. So with projection, you always lose something. So there's no magic perfect solution. So the question is that what do you want? What are you willing to compromise here? And so things that get messed up with projection are basically these four. So depending on what projection you use, the areas can get distorted, the angles can get distorted, directions, and distances. So based on what is the purpose of the map, what is the scale, what do you want the map for, then you choose, okay, what am I okay with like losing? So for example, if you're using a map for navigation, then degrees are very important for you. So you want to use areas are not important. If you want to go like sail from Europe to across Atlantic to the Americas, you don't care how big is the continent. What you care about is to get the direction right. So you want to use a projection that keeps the directions correct, the angles correct. So we have used different approaches for projection, but classically we have used these three shapes, the cylinder, the cone, or azimuth to do the projection. So generally speaking, sorry if this is too small, we have four groups of projections depending on what you use. So you have conformal projections that keep the angle, preserve the angles. Then we have equal area projections that preserve area. We have equidistant projections that keep the distance correct. And we have compromise projections. So these are a bit more creative. So they have come up with like compromise. So you lose a bit of this and that, but generally you have a good representation of the map, the world, or whatever scale the map is at. So again, there is a lot of theory here. And if you're curious, there are a lot of books out there, resources to learn more about this. But generally, this is the idea behind projection. So you have your Earth, you have the globe, and then you use those surfaces and you do some mathematics to do the projection. So you might use a cylinder, which works nicely, as you can see, for the equator, or for more northern areas, like in Finland, we use the transverse cylinder. So you put the cylinder the other way around. You might apply a cone, which works nicely for like mid-latitude. So like for Central Europe, these cone projections are common. And then we have the azimuthal projections that work nicely for the North Pole, for example, and the South Pole. Yeah, so the main point here is not to learn about the projections. Well, it is important to know about them, but the main point here is to remember that it's a very important part of cartography. And it's been misused for a very long time. For the reason is that one, it's a bit complex. So if you're not comfortable with the mathematics behind it and understanding what is happening, then it's easy to avoid that. Another reason is that maps have been made for a long time by people, especially when you started to have all this nice software, QGIS, ArcGIS. GIS and cartography started to seem approachable. So we have people who have not studied GIS, but they just learn how to work with ArcGIS, and they produce a map. So the goal is to just get something out. They don't bother to think about what is happening. And another reason why we have become a bit lazy with projection or thinking about projection is that the modern softwares or even libraries are very good at handling this. So you just open your QGIS or ArcGIS, you import your data, and if a transformation is needed, it just does it on the go. So you see the correct map in most cases, unless something is off with the data or projection. So we have become a bit lazy with thinking about it, but it's very important, and it really affects the looks of your map and how accurate it is. We have some established habits. That's also another reason why we don't think about it. So you are so used to seeing the world as that, like the Mercator projection, which is criticized quite a lot. So you just continue with that, and the world looks correct to you, even if it's not. Like look at the size of the Greenland compared to Africa. Well, that's wrong. Africa is, I don't remember the exact number, but it's like many times bigger than Greenland. But that's what Mercator does. And many people who are not familiar with geography might just accept that as the fact. Yeah, so remember that what is popular or well established is not always good. An example of that is Mercator. So what Mercator is that, well, it was made for navigation. So it's a conformal projection that preserves angles. So it was created and became popular when we were sailing or traveling long distances. And that's a great projection. But what it's not good at is like creating a representation of the world, because it's just not, it exaggerates areas, especially toward the North and South Pole. So why is Mercator so popular again? The reason is that, well, it was popular to begin with. It was used a lot in navigation before we had computers and internet. But then when internet map services started to emerge, they adopted Web Mercator for a number of reasons. So Web Mercator is basically Mercator with some optimization for how it works on computer. But it was convenient. Well, first of all, it was familiar. The mathematics behind Mercator are simple. So if you're using Google Maps, if you're creating a service like Google Maps, you want it to be fast. You don't want to spend, for each click, you don't want, or for each change on the map, you don't want to wait for, I don't know, many seconds for it to load. So Mercator is efficient. Another good thing about Mercator that made it popular for web is that you end up with this rectangular worldview that allows you to create that grid network. And because the angles are not distorted, you end up with this neat grid system, which is perfect for web use. Because the maps, when you open Google Maps, not the whole world is loaded. It goes tile by tile based on what you're viewing. And it works perfectly for this tile system. So you create this grid of tiles with Mercator, and then based on the zoom level and where you're looking at, it will be loaded. So yeah, so it's a Web Mercator. Web Mercator is basically Mercator with some changes. For instance, if you look at Google Maps, Greenland doesn't look as huge as it should using Mercator. So they have done some compromise here and there to make it a bit more balanced for the north and south certain areas. And in many of their calculations to speed things up, they don't actually use ellipsoid. They use a sphere. So I assume the Earth is a sphere, which again causes a lot of inaccuracy. But then what do you use Google Maps for usually? You don't use it for, I don't think commercial airlines use Google Maps to fly long distances. So for everyday navigation, it's fine. But anyway, because of these online maps, we have gotten so used to using Web Mercator that we don't think about it anymore. And that is bad. But yeah, so the main point, think about your projection, see what is best. If you want to follow what is already established or seems to be working in your local area, then there are a lot of information depending on where you're doing your analysis, where your data is coming from. But in Finland, most of you are familiar that we use the EUREFIN, which is based on the European Terrestrial Reference System 1989, ETRS 89. And if you need a projected system, then we often use this TM35 fin, which is transverse Mercator projection. So yeah, so familiarize yourself with projection, see what works best. But in Finland, we usually end up doing this. Yeah, so before I continue talking about how we can make nice maps, let's do a bit of activity. So scan this or just type in the address. We have a Flinga board. Just write whatever you think makes a good map. OK, you can still add in things, but I start to go through some of them. We already have a very good starting point, and I can see most of you have great ideas how a map can be done better. A lot of it I can see is about visual hierarchy. Yep, so there is one comment there. No mixing of green and red. That's a very good point because of the color blindness issue. We are going to talk about colors quite a lot next week, and also visual hierarchy. It's one of the most important things for producing good maps. Then the main message of the map is shown first, again, related to visual hierarchy. So you should think about, this is something that we very often miss, but you have to think about what you want to prioritize in the map. So and the size is one of the main things determining the visual hierarchy. Another thing that has come up a few times is the coloring. So color is important in a number of ways, but one of the reasons it's important is that it has a big effect on visual hierarchy. So for example, if you look at this, the first things you probably notice is the red and the green here, because they're very dominant colors here, and there's a lot of visual hierarchy there. Like it's prioritized. So coloring is important. Beauty matters, of course, with cartography. Crisp borders, yeah, we want things nice and neat. Accessible colors, easy to understand, clear place names, scale, good color scheme, legend. Yeah, so a lot of the comments are about the elements of a map that we are going to talk about soon. So legend, north arrow, scale bar, these are some of the elements. There was one comment that is interesting, but I don't fully agree with it. Well-analyzed maps, that's important, of course. If you don't have good analysis, if the data is not correct, then whatever, no matter how beautiful your map is, it's just wrong. But not always a lot of information is good. So this is something we are going to talk about a lot. So putting too much in your map, unless it's needed, is not always good, because you just overcrowd the map. So it's good to be selective and not put everything there. What else? Visually appealing, clear, well thought, consistent coloring, relevant size, understandable to everyone. Yeah, so it's important to take audience into consideration as well. Yeah, so a lot of good things have come up. We are going to visit many of them today and next week and following weeks. So let's get back to the slides. Yeah, so a lot of things that you already pointed out were about cartographic grammar. So what is cartographic grammar? The rules and guidelines that have been established over centuries how to produce good maps. So it is a good thing for especially people like me who are not born as an artist. So this grammar helps me to have a good starting point. So if I'm not sure what color to choose, if the color doesn't speak to me like that, then I have guidelines. There are a lot of guidelines out there, like how to choose the coloring. So that's good. So we have a lot of rules and guidelines. So they're not often enough. You have to couple the guidelines with creativity to get the best result. So one of the problems we have with cartography is that those people who have not studied cartography or GIS enough, they're not aware of this grammar. So they don't get the rules and guidelines in their maps right. And you can implement these guidelines with the software we have, but they're not automatically implemented. So if you just put a legend in your map, in QGIS, it just puts something default. It doesn't think about the visual hierarchy for you. So that's why these are not, so you have to be aware of the guidelines and then implement them, because they're not automatically implemented by any software. Maybe later with some AI-assisted tools, but not yet at least. Then we have the map elements. We have a lot of elements that you already pointed out, and we go through them in the next slide. So if you look at that map, it doesn't necessarily look bad. It takes many of the points that you already brought up. So it has decent colors. The boundary is crisp, as one of you mentioned. It looks nice enough. But then again, the map is not informative. It's not usable for a number of reasons. And the main reason is that it's missing some elements. So if I look at the map, I can kind of guess that probably that blue polygon is referring to a lake, but I can't tell what those points are. So without a legend, and legend is just one example, without having the necessary map elements, it's a bit hard to read the map. So this map could have been a nice map, but it's very useless now without those required elements. So classically speaking, these are the elements that you see in the maps. So the map itself is an element, so it's important to think of it that way, especially later when we start to talk about map hierarchy, visual hierarchy. It's important to think of the map as one of the elements. So you have to adjust where it is in the hierarchy of your map. So then we have title, legend, scale, orientation, and metadata. So one mistake that very often people make is that they think you have to put all of them in your map. And that's a mistake. You do not always need to have all of this. So you should just choose the ones that are necessary for understanding. So don't overcrowd the map. So you do not always need to have a north arrow. It depends on the purpose of the map. You do not always need to have a title for your map. It depends on how you're presenting the map. If you are having a map in your thesis, in your scientific article, and there is a subtitle for it, and there's text, then you don't need a huge title necessarily because the information is there. So it depends on where you're putting it. So these are elements, and very often we think, okay, in order to do a good map, I need to put all these things. But often you don't need all of them. So it depends on the purpose. If we look at cartography books, there are extended lists like this as well. So there are these primary elements like title and legend and north arrow. Then there are these secondary elements that are less often used, but depends on the type of the map. Yeah, so you might end up adding a logo if you're working for a company. So that can be considered a map element that you do not always need it. You might have insets, you might have information about the projection. Again, it's a good piece of information to include, but if you're making a map for people to find tram routes in Helsinki, do you need to specify what projection you're using? Probably not. So too much information is too much. So these are elements that are available to you, and they're very often good to use, but you do not need to use everything. That's the main point. So don't fall into the trap of putting everything. Just think about what is the map for, and decide what is needed to be there. Another important thing that again came up in your comments was map symbols. So in your map you have items representing different things. So you have a lake, you have a hospital, you have a house. You have items that they are showing in your map. So you use symbols to show those items. So you have geometries in GIS that you work with. You have point, line, area, or you want to make things complex, you might have more sophisticated surfaces and 3D objects. But generally speaking, you have points, lines, and areas. And you use symbols to visualize those. Generally speaking, we have 3 types of symbols. So symbols can be pictures, like the first one here. So you have a house here. It's a picture of a house. So you probably would use it to show residential areas or a house or something related to that. So this is a picture of the thing. Sometimes it's associative. So it's in the middle one. So where would you use the one in the middle? A hospital. So it doesn't really say much about hospital. It's just you have learned to associate this with a medical place, medical center. And this is very cultural based. So this cross may not work everywhere in the world. So when you're using map symbols, it's important to think about the context. Who is this map for? Across here where you are might mean a hospital, but if you use the same thing in another continent, another remote place, it might not necessarily mean the same thing. So we have associative symbols, which are a bit context-based, so you should be careful with using them. And then we have abstract symbols that they don't really mean anything. It's like, for example, that pin doesn't really mean anything. It's just an abstract element that we are used to using for showing a point of interest, for instance. So for your symbols, you end up using one of these 3 usually. A picture of something, an associative symbol, or something abstract. But the item, when you're working in GIS, well, you have the items, but very often you have other columns in your data. So the item alone is not enough. So you might have residential buildings that you are visualizing. So you will, okay, it's an easy decision. You will go with a symbol like that, for instance. But you also have information about how many people are living in each of those houses. Very often we have that kind of information. So you have information about the density. Or you have hospitals, but you also have information about what is the capacity of that hospital, how many beds does the hospital have. So you have usually, very often, another column. And for that, you use visual variables to show those other attributes. So this is, again, another classic cartographic concept that was first brought up by a French cartographer called Jacques Bertin back in the 60s. And then over the decades, of course, a lot of things have changed. So there are a lot of versions of this that you can see in different books. But the idea is simple. So you have some item that you decide to visualize with a shape. So you have different items. They're distinct. You're showing hospitals. You're showing houses. You're showing trees. And you go with different shapes because there are different things. So that's one visual hierarchy. You're distinguishing very different classes with different shapes. But sometimes you want to have a bit of hierarchy. So you have houses that you're showing as a square, but the houses, you want to visualize how tall the house is, or you want to show how many people live in the building. Then you would adjust the size. So you will use size as a visual variable to portray the change of that attribute, which is the, for example, number of inhabitants. So there are different things you can adjust, like color hue, which is basically, we are going to talk about colors, but basically different colors. So these are different colors, so I cannot say if purple is more or less than red. So there is no hierarchy here. It's good for like nominal classes. So you have different land use. So this is green, this is blue, this is, I don't know, different kinds of soil types. So different nominal values. But with adjusting, for example, brightness or saturation of your color, then you can show a bit of hierarchy. So showing the density. For example, you will use something like this in a heat map. Again, depending on the map, you might have direction, for example, for the climate maps, weather maps. You might have direction of the wind. And then again, very often you end up using a combination of these. So you might have this showing the direction of the wind, but you may also want to show how strong the wind is. Then you would adjust the size of the arrow in relation to the speed of wind. So you may end up with a combination of this. And there are, in newer books, there are other things as well that originally were not thought of before computers. So we have the 3D elements as well. We have transparency that we can work with. Before computers, it was a bit hard to work with transparency and different things. So this is another version of this from another book. Idea is the same. The main message on this slide is that table. So there's a limit how, we are going to talk about classification later on, but there's a limit how many different classes you can distinguish. So if you have different sizes, your eyes cannot, if you have like 20 different sizes in the map, for your eyes it's different to distinguish all these 20. It's very difficult. So it only works well if you have dots, for instance, and you want to use size as a visual variable. It usually works around 4 classes. So if you have 20 classes, then maybe size is not the best visual variable to choose. These are not, of course, exact numbers. These are just some guidelines for you. If you're using different color hues, up to 7 colors usually works well. If you have like 20 different colors, well, first of all, you might run out of like distinct enough colors to use. But also, it's very confusing for the person reading your map. They have to constantly look at the legend to know what the color is. So this is just some rough guideline. If you're going with color hue, different colors, stick to 7, 8 classes. With orientation, 4 if you're with dots or with dashes, and so on. So visual variables. This is a map from 2017 from HSL. So it shows the tram lines. Let's take a couple of minutes. You don't have to move. Just talk to whoever's sitting at your desk and talk about these things briefly. We have like 5 minutes. So talk about visual variables. From what we already talked, what visual variables do you see here? How do you think they're working here? Are you happy with how it has been designed, or would you have done something better? Is there something you dislike about visual variables? Yeah, so talk to your neighbors for a couple of minutes, and then we will come back here. Yeah, so there are a lot of things that can be improved, and I agree with you. But one thing that is, I guess, relatively good is the use of visual variables, and you see a lot of them. So we have different color hues. So you have different colors: blue, green, red. Of course, you have the classic mistake of combining red and green, which is hard to read for colorblind people. So there is color saturation. So there are different saturation we are going to talk about is basically making your color impure. So you have a pink color, then you add a bit of gray to it, you end up with something like that. So that played with color saturation. There's different levels of brightness, different symbols. They have used like patterns to added a bit of texture to distinguish the train line. Yeah, so there is a good example of using color visual variables. There are a lot of things that can be improved. This is a later version of the same map. And I honestly like the original better. Like, I don't know what you think about it, but I don't understand the point of this very vivid neon colors used, like this green. It's a bit annoying, but is anyone who thinks differently? Yeah, I like the earlier version better, but yeah, relatively good use of visual variables. So talking about map elements, things have also, of course, changed. Now we have the interactive maps. An interactive map, you have other elements that are not relevant to paper, or when you have a static picture exported. So you have map selection, you have navigation, you have zoom level. These are also map elements. If you end up creating interactive maps, which we will do toward the end of this course, then these are elements that you should think about. Do you need to have a zoom button? Do you need to have selection? Is this something that your user will need? And do you want to add other functionalities? Do you want to have a search box? So these are, with interactive maps, there are a different set of elements that you should think about. Do you need a scale bar? How should it look like? And different things based on the purpose of the map and who your users are. So types of map, I try to be quick here so we can take a break and then continue with Mikko. So maps can be divided into groups. So we have thematic maps and we have topographic maps. So topographic maps contain a diverse set of data on different themes. So a good example is a lot of the maps that we use for like hiking, for instance. They have a lot of different things. On the other hand, thematic maps usually show data relating to a particular theme. So for example, what we just saw. You have a map about tram lines. It has a specific purpose. It doesn't show everything that is in the center, but a certain topic. So you can have a map of land use, car accidents, population, tram lines, anything. So these are things that you probably have seen in your other courses before. So different thematic maps. One of the most common types that we see a lot and we work a lot with is the choropleth map. So they are made of polygons, and the polygons have different visual variables. You show different kinds of information. Yeah, and I guess choropleth is a Greek word. Chorop means area or region, and pleth is like measurement, something like that. Yeah, so you work with polygons. Then you have dot maps, density maps. Then you might have graduated symbol maps, where you have, like, for example, a map of airports, and then you're visualizing them, for example, as an airplane, and then the size is relative to number of flights per day, for example. You have heat maps, you have cartograms, flow maps, and isoline maps. And many of these maps we are going to create during this course. Not all of them, but many of them. For example, the flow map and cartogram and heat maps and a few more. So this is, I put a picture of this slide also on the course's website. And I guess this kind of summarizes this course quite well. So we want to see what makes a good map. That's the purpose. We have been producing maps, and now we want to make them better. And in order to achieve that, you need to first understand what makes a map good. So what are the guidelines? What are the elements that you need to know about to create a good map? And the other thing is the technical skill. So it's not only enough to know, okay, what makes a map beautiful. You should also be able to do it in QGIS or whatever tool you use. So that's kind of the goal in cartography and what we are trying to do this month. So what makes a map good also depends. It's not as simple, but there are some design elements that we will learn about. But also you should take into account who is your user. A map that might be great for a certain audience might be terrible for another audience. What is the purpose of the map? What is the culture and the context of the map? What are your resources? Like, do you have do you have the resources to use a certain tool? Do you have Python installed, for instance? Do you have access to that, a certain software? What is the media presentation? Are you going to show it on a screen like this? Are you going to publish it on the web? Or are you going to print it out and have it on paper? So these are some of the things that you should think about. And again, we will go through some of them during the course. So this is a quote I read in a book, and I liked it, so I added here. So a world is a canvas, and we are the artists who bring it to life through our maps. So it's a bit of extra motivation for you to think of cartography as an art. And if you think of it as an art, then you're in a good place, actually, because you have a rich palette as a cartographer. So you have all kinds of tools that you can use. You have all kinds of colors that are available to you. You have all kinds of geometric shapes, lines, polygons, points that are in your palette. You can use them to create beautiful maps. And all the elements we have been talking about. So you're in a good place. You have good tools. Cartography combines aesthetic expression with scientific technique to convey geographical information. It's important to think of maps as not just tools, as also a piece of art that tells you a story. The storytelling is a theme that we are going to highlight in this course. We are going to visit that later. Yeah, so a lot of things that we are going through is like very quick things to just get you started for your first exercise, but we are going to return to many of these and open them up later on. So quickly looking at the layout design. So I already said that you can see the map as an element in your map. And it's, of course, a more kind of, well, it's the most important element in your map because that's the purpose of the visualization. So there are a number of things that you think about to make your map look professional. So look through the list of all the possible things that you want to add to your map, list of all the elements that might be relevant, then decide which one should go to the map layout. So like I said before, there are a lot of elements that you can choose from, but choose the ones that are relevant and you want to put them there. And then you go through this iterative process. So choose what you want to draw. Very often people start with the sketching. I sometimes do it. So you take a piece of paper, design the layout. Okay, where do I want to put the legend? Where do I want to put the map? What elements do I need? Then you just shuffle it around and then come up with a good solution. Very often it's good to get feedback from others. Something that might look nice to you might not look nice to others. So very often you go through this iterative process of adding things and moving things around. Again, a lot of these things are a creative process, but for those of us who, I know, being creative right away might not be easy for everyone. So there are some guidelines like how to work with this. So for example, with the layout, these are a few options that are available to you, like classically in cartography. So where do you want to put your title? So of course you can put it in different places and it gives a very different vibe to your map. So whether you want to include a title or not is another question, but if you include it, then you should decide where to put it and how the map will look like eventually. You can be also creative, like I saw in one map that they were talking about birds that are going extinct, and to make it a bit more interesting, they had to use something like that. Like, I haven't done it so nicely here, but the text was fading, so to kind of give you a feeling of like birds disappearing or going extinct. So you can be creative in this kind of ways as well. And we are going to talk about font and color and those details later on, but for now, let's think about where you want to place your title, whether you need the title, and where you want to place it. And you can see you end up with very different looking maps. And next week, we are going to talk about map visual hierarchy. And this also affects the hierarchy a lot. Like here, you can see the title is not very highlighted, so it's not the first thing that people notice. But here, for instance, the title is very emphasized. Colors in cartography, again, this is one of my favorite topics, and we're going to talk about this the whole next week. But already this week, when you're making your maps, start to think about colors and try to be creative. Like, as I said, as a cartographer, you have a rich palette, a lot of tools that are available to you, and I think one of the most powerful tools that are available to you is the use of colors. And they can significantly affect how your final map looks like. So how do we work with colors? So it's a combination of things. So there are theories that we will go through. There's color theory telling you what colors work well together, for instance. So those are things that are good to learn. There are some rules also, like what colors to use together, what are, like in cartography, certain colors are used for certain kind of items. For example, there's a rule that, okay, if you have green spaces, it makes sense to use green. Don't go with some weird color unless you have a good reason. So there are those rules. There is some color theory, but also there is inspiration. And later next week, we will see that that inspiration doesn't necessarily need to come from maps. I very often, for my maps, and I will show you next week, I get the inspiration from like paintings. So you see a painting and you see, oh, these colors really work nicely together. Why not? I can use it in my maps. So that inspiration can come basically from anywhere. So try to already think about it from this week. Yeah, so the references for things we talked about today. Yeah, that's all for now. Let's take a break for maybe 10 minutes, and we'll be back here and we will continue with Mikko. Yeah, so some of you might know Mikko. Mikko was our student here. He graduated, was it last summer?
Yeah, this was my last course.
Yeah.
Yeah. So hi everyone, I'm Mikko, familiar with some of you already. Gonna be explaining a bit about my cartographic journey, as well as my current work, and then my final project for this course last year. So yeah, as I told you already, participated in this course last year. It was my final course, and did my MSc thesis about monitoring mountain biking with sports tracking data, more specifically Strava data, if you're familiar with that app. And currently I'm working in Posti as a GIS developer, so working a bit on more technical stuff. I'm sure you're all familiar with Posti, needs no introductions. And I'm a big advocate for open source GIS, and I'm glad that in Posti I'm working a lot with moving away from commercial providers such as Esri. So I was going through my my course material from previous years, and here's a map from my second year GIS course, GIM 2, and pleased to say it's not my finest work. I must have been in a hurry. So do you have some ideas on how it could be improved? You can just throw ideas around.
It's quite hard to see what it's about.
Yeah, definitely. Yeah. Yeah, so maybe like the visual hierarchy and placement of the map items is not ideal. And these are some of the kind of lessons that I learned on this course and in other courses as well. So I think the most important for me has been to have one thing stand out of the map, like to think about what your map is really about and what will the viewer like first focus on when they see the map. And then if we look at this one, the main focus should be the daycare centers that are the actual data points. But then the legend is probably the first thing that they see, since it's like huge there. And then second thing is probably those huge north arrow and scale bar. And then the actual data is really small. Then the second thing is that using all spacing efficiently. So you have quite limited space on your map canvas, so you should use all space that you can without like making it too crowded, leaving some breathing room. And then also making compromises when possible. Think about like what can you leave out of the map without misleading the viewer. So here, probably what I could have done would have been that I would have brought those two daycare units closer to the other ones, maybe make like an inset map or like an arrow there, so I wouldn't have this giant empty space in between. And then also the fact that every single one of them says päiväkoti might have been could be made like a little bit differently. And then also I have a huge empty area in the legend, so I could have placed the north arrow and the scale bar there. So then here's what I think is one of my better maps, which I made for my master thesis. So I had a really difficult time making the maps for the thesis because my research areas were like 3 large national parks. Pallas Ylläs, Urho Kekkonen National Parks and Pyhä Luosto National Park. And then, so the map is representing like Strava activities on mountain biking trails, so pretty much amount of mountain bikers. And the problem was that there are these areas that are really crowded. There's a lot of trails, a lot of activity, but then there are also activities in all the way on the other side of each area. So I had to find a way to kind of not make those crowded areas too busy so you couldn't see what is happening, and then also showing the entire area. So I decided to do these zooming in sets. And then also, since the map is representing like a trail network, it's really difficult to show it clearly without it becoming like blurry. So then I decided to leave like everything out of the map, like put a really light background map that barely has any detail, and then put the trails as like bright red, since that's the most powerful color that viewers first focus on. And then the thesis already had like a general map, so the viewer had some idea of what these areas are and what are like the central areas. Then one year I also participated in this 30-year map challenge. So it's a kind of like a social media challenge every November where people make a map every day of November. And always for each day there's just a really general kind of topic. So for the left map the topic was just hexagons, and for the right one the topic was just red color. And making this, I noticed like how difficult it is to make a map out of like nothing. You don't have any data, just have a really general topic. And it was also kind of liberating to make a map just for fun, because you don't have to be so scientifically accurate. You can just focus on it like looking cool and stuff. But then of course, since I made these maps in a day, there are some problems that I noticed afterward, like the Baltic Sea. I aggregated like a raster depth data to these huge hexagons, and then it averaged out like below sea level in Åland and some of the islands, so kind of drowned out huge land areas there. But yeah, you have to be also careful with that. But if you never, yeah.
In what program do you did these maps?
They are in QGIS. So, and pretty basic ones. So just simple, maybe one geoprocessing, and the traffic noise is just the ready data sets from Väylävirasto. So yeah, if you've never like just made any map and like just without any kind of guidelines or anything, just for fun, I really suggest it, because it's a real challenge.
Yeah, sorry to interrupt you, but like this is what I was like trying to say earlier today, that like the analysis is not so sophisticated. Correct me if I'm wrong.
Yeah.
What makes this map look very cool is that you have been creative. So it's like the usual GIS analysis that with your choice of colors, you have made this map look very different, and also the font and everything. Yeah, so that's what I mean by creativity, not taking the same approaches necessarily, but being brave with the design and trying new things.
Yeah. So then to my current work at Posti. So I'm not really, that's why you have to enjoy this course, because when you get to work, you don't get to do any maps. So it's more technical stuff usually. So this is an application that we made to track the journey of mail items. So it collects data from like multiple SQL warehouses and combines them into this intuitive UI. And here kind of the same visual rules apply as for making maps, like visual hierarchy and stuff. So what I first want the user to focus on here is, well, first of all, it's easier with an application because before the user tracks any shipment, they don't see anything else than the track shipment button, so it's easy to put their focus there. But then after they get this dashboard UI, the first thing I hope for them to see is the recipient and address table, which is green if everything has gone normally, and then it's bright red if everything has gone wrong. And then there's just a simple interactive map which connects with these numbers to this kind of tracking history, just kind of like the legend for the map. And there's a bunch of details about each event that the mail item has gone through. And here it really shows that like making a static map is probably one of the more difficult tasks, since you have so much room to play with on this kind of even light application. You have like pop-ups and lists that you can scroll and stuff, so you can include much more information. But then it's great if you know how to kind of prioritize so it doesn't become too overcrowded. And then a bigger project that we're working on is making this kind of generic map portal. And I want to highlight this because like I've been really nerding about WebGIS the last year, and I'm really deep in this rabbit hole. And it's when you have more than couple of layers and it becomes even a bit more complex. There's like a lot of like technical things that you need to do in order to make it work, like tiling and spatial queries, spatial APIs, rendering, and so on. But luckily there are some open source frameworks. Some of you might notice that the portal looks familiar because it's the same framework as like Paikkatietoikkuna uses and most Finnish map portals. But I really suggest to, maybe it's a bit outside of this course topic, but I really suggest to look into like how these kind of map portals work technically, because it's really interesting stuff. I was trying to find some material, but I couldn't too much. It's has been more like trial and error for me. And then on to this course last year. So I of course chose my best maps of the course for this presentation. So it's kind of actually blown out completely because of the presentation, but it's from Helsinki and there's some detail on the background, but it's not showing great here. But these are bike sharing trips visualized by this edge bundling technique. So the data is just origin destination pairs. So, and then without the edge bundling, it would just be like direct lines like all over the place, so you couldn't see any kind of patterns. But what the edge bundling does, it bundles together the lines that go to the same destination. So it moves their geometries to these kind of curved lines, which looks pretty cool. And then also I used this, since the data didn't have any kind of attribute data on how many trips there were just the geometries. I used like blending modes in QGIS. So I duplicated the layer like 3 times and then did different blending modes. So each of them are a bit transparent, and that made kind of the highlighted areas pop out a bit more.
So Mikko, for this did you use QGIS or Python?
The edge bundling was like a ready tool made by Digital Geography Lab, and that was just a Python script that took the data and bundled it together, and then the actual visualization I did with QGIS.
So the person from Digital Geography Lab who has developed this is visiting us next week, Tuomas Väisänen.
Yeah, Tuomas will probably explain something about the tool, since it was quite a like advanced technique for visualization. Then for my final project, I looked into temporal patterns of park visitation in Helsinki using mobile big data. So platforms such as iNaturalist, which is like bird watchers and like nature enthusiasts making the data points, and then Flickr, which is this photography social media platform, quite an old one, not used so much anymore, and then Strava, which was the same that I used for my thesis as well, for sports tracking data. And these data sets were aggregated to each park, and then I first represented the data with like simple graphs and static maps to give like an overall view of the area, which are the most popular parks, like what are the temporal patterns of visitation. And then the kind of bigger work was this interactive map that shows, first visualizes each park with the most popular platform, and then once you click the park, it shows the temporal visitation, so hourly visitation pattern, then weekdays, and then monthly visitation with the different data sets. And I used a combination of different tools for this. So I made the static maps with QGIS, and then the graphs with Matplotlib in Python, the interactive map with Folium in Python, and then I used like HTML to just make this kind of scrollable report that I could share. And this was an initial design for Digital Geography Labs project with City of Helsinki. And after my presentation, we can look into the final map, which was partly made by me and then finalized by Tatu Leppämäki. And I think it's a really good example of an interactive map. So some tips for the final project. So I think the more maps and more work you see, the like more ideas you get, since all of my ideas are like something that I've seen somewhere, maybe combined a few things to make it my own. So draw inspiration from articles, Reddit, LinkedIn. So usually you can trust like scientific articles to have good maps, not always, but most of times. And then to see like more artistic, cool looking maps, there's a lot of good threads in Reddit, and then usually you bumped into some nice maps in LinkedIn, and there are some profiles that do a lot of them. And I really suggest making something interactive, since like you've probably made 100 PowerPoints and Word reports and static maps already. So I really suggest like taking the extra time and making something interactive. And it's especially now when AI can help with like the boilerplate code, shouldn't leave the creative process to AI, and I think your guidelines also allow it. So there are these really easy Python frameworks like Streamlit, and here's just an example of what a kind of typical Streamlit boilerplate code does. So it just reads from top to bottom. You can add interactively like sidebars, headers, and the headers are just like markdown text, so it's pretty easy. Yeah.
What's boilerplate code?
It's kind of like you have to write all of these, like make like the initial structure for the app, or like headings and stuff like that. So you don't have to then like look each line up, like how do I do this, how do I do that? And then you can actually just write the kind of content yourself. So yeah, you can just add like sidebars, interactivity, slideshows, interactive maps, like Streamlit, for example, goes really well with Folium, for example. And then, as I did in my final project, like I suggest using multiple tools. So I remember that I did my first Python map on this course, and I really didn't enjoy it since I'm so used to QGIS. So if you can like do stuff with the tools that you're most familiar with, and then just combine a bunch of different tools to make something interactive. And then there's this like ArcGIS story maps kind of framework with Esri, kind of like an interactive blog or like a map blog. And they are pretty cool examples, and you can do a lot of the same stuff as the story maps does, you can just do with Python frameworks as well. And this is from like when I was on exchange in New Zealand, they showed it to us. It's about like the Alpine fault in New Zealand and earthquakes and stuff, but it's just has really cool visualizations and like really well put together story in form of maps. So I suggest looking at that. All right, thanks. Here's some of my references and then some inspiration, like an example of a cool Streamlit application as well. And I think I can now show like the DGL's interactive map.
Yeah, you can. It's extended, you should find the mouse pointer there.
This is really difficult.
Yes.
Okay, so the concept that we came up with, or we didn't come up with, we saw it in another article, is these like park cards. So kind of having like a really like one page, really concise report of the visitation of a single park and having as much information there as possible. And then we thought that instead of like having a typical kind of just folder that has a bunch of maps there and the user has to scroll, then why not like put it in an interactive map? So maybe I'll zoom in a bit. So in my initial work that I did for this course, I just had the different graphs, and then the final version we did has like, so there's this static maps. This was made with QGIS and automated with the Atlas function there. So it shows the data points for the different social media platforms, shows how popular different cycling routes are with Strava. Then it shows the monthly, weekly, and hourly visitation patterns. Depends a bit on the park, like which data set is used. Then there's also a picture of the park, a brief like just explanation on what it's known about, what people usually do there. Then there's this ranking with the social media data, like what does it rank for every park in Helsinki. And then there's also this word matrix to show like most popular hashtags and words that were used there. And I think this is a cool example of showing like a huge amount of information in a really visually pleasing and easy way. Easy for the viewer to see at least. And then it's also easy to kind of share these, put them to reports and stuff like that. And you can look into more, maybe see some park that's close to your place from the link in the presentation. All right, I think that's all for me.
Yeah.
Thank you very much.
Thank you, Mikko. Okay. Do you have any questions from Mikko? Okay, so this gives you a good idea of what we are aiming for. Well, Mikko did a great job with his work last year, and I'm sure all of you will do a great job as well. But you kind of get an idea of what we are aiming for. So many of the things you did, we also learned during this course. Yeah. So now that you brought this up, I can, and we still have time, I can still, maybe you can.
Yeah.
Yeah. I will show something on the course's website still. Yeah, thank you. Where's the... So one of the main ideas we are promoting in this course is to learn to tell a narrative with geographical data. So we'll start talking about this from next week on. So the idea is that, okay, what you're doing with geographical data, you want to tell a story. Sometimes the story is short, you just have a map, you present it. Sometimes you explore it a bit further. And that's the idea behind the portfolio we have at the end. I will try to publish it already next week or the week after, so you don't have to do all the work in summer. You can start thinking about it. Why doesn't this work? But yeah, so you pick a topic and then you do your portfolio. So you explore the topic through different visualization methods. And one of the things we will highlight in one of the weeks in this course is that, of course, when you're working with geographical data, the main way of exploring the data visually is to make maps, but it's not the only way. Like Mikko showed that he also used some charts to explore certain aspects of the geographical data. So there are also non-cartographic ways of visualizing geographic data that we will briefly look at, but of course it's a course in cartography. It will be mostly about maps. But yeah, more information will come about the portfolio and the storytelling. Where did this disappear? Another thing I wanted to talk about now that we have a bit of time is the Python versus QGIS question. Okay, something I forgot to show at the beginning is the topics for the course. So many of the things Mikko mentioned will come up during the course. So first week we had some overview of many different things. Next week we will have Tuomas coming here talking about his tool. And each week we have a topic for tutorial and for the lecture, and we try to keep them in balance so they're related things. So next week we will work with color theory, and we will have also the visual hierarchy. On the third week, we will have Marco Kallio visiting us again. He came last year as well. He has made a very beautiful map of a river in Asia. And we will also talk about storytelling and map media. And on the fourth week, we have Pyry Kettunen coming from National Land Survey of Finland. He will also talk about geovisualization. You can see in the fourth week, we start working with interactive maps. So you will also learn how to make interactive maps. And this is one of the things you can include in your final portfolio. QGIS and Python. So we already did a poll on Moodle. I cannot show the results because the names are there, so I won't share it. But like more than half of you had said that you are more interested in using QGIS. A few of you had expressed interest to also use Python. And a good share of you also said that you're interested in exploring a combination of both. And like Mikko said, very often in real work life, you end up using a combination of different tools. So it's good if you practice it. And you may be asking, why should you bother to use Python for creating maps? Because like also Mikko said, it's a bit tricky. You're so used to this interactive environment you have in QGIS. You zoom in, you zoom out, you drag and drop things. Of course, in Python, or if you use programming, you don't have all those fancy tools available to you. But it's very useful, and you will hopefully see it during the course. A number of reasons why you may want to use programming for visualization. One of the things is that, of course, you're in control. Now, if you're using QGIS, you depend, unless you make your own plugin or something, you depend on what comes as a package in QGIS and what plugins are available. If you have a very novel idea how to visualize a thing, and there is no ArcGIS or QGIS tool for it, will you just give up on the idea or try to just make your own code? So if you know programming and you have some very novel idea, you can just make it happen. So with programming, you have more freedom. Some things might be a bit more tricky, but at the same time, you have more freedom. So if you have some novel idea, you can make them still happen without depending on a tool, ready-made tool. Another reason why some of us might use programming for a programming approach for cartography is automation, like in many other GIS processes. Depending on what kind of tasks you will have in your studies or in your future job, there might be a need to produce maps in large scale. So imagine if you're producing maps of all national parks in Finland, and as long as it's a standard kind of map that you want to repeat, you might come up with a way of automating the process. So you can just write a piece of code that can partially at least automate the process of producing maps for different neighborhoods in Espoo or different national parks in different areas. So if you're producing maps in large scale, that's another motivation for you to use programming for creating map, because you can automate the process. Doing that in software is not as easy. Yeah. Do you find any other motivations for using programming for cartography?
Well, yeah, also with Streamlit, for example, and some interactive maps, it's a really nice process of making it, because it updates instantly when you change your code. So you can just have the map on one screen and code on the other, and once you write a new line, add a new element, it just pops right in there. So sometimes it's even better than a desktop workflow.
Yeah, that's a good point. Another thing that just came to my mind is efficiency. Like in one of the weeks, I guess week 3, we are working with big data as an example, and we produce a hexagon map like what you showed. And you will see when we are working with very large data sets, generally speaking, programming is more efficient if you're handling, if you're working with big data. So that's another motivation for many. You're using with large amounts of data, and just with programming, you can optimize the process compared to software, which might just crash if you're loading a very large data set. Yeah, okay, that was all for today. If you have questions, you can ask. If not, we can finish here. We will meet next Wednesday. So remember, next Wednesday, not Tuesday.